Last time, row operations became left multiplication by elementary matrices. Today we use that machinery to turn a matrix into row echelon form. And then read off rank and nullity without pretending the numbers came from a crystal ball. Here is the matrix A. We want to find rank A and nullity A. The plan is to use row operations to make the matrix easier. Then justify why the easier matrix has the same nullity. Computation with an alibi. At last. Before reducing the matrix, let us say what row echelon form means. First, all 0 rows, if any, must be at the bottom. Second, the first non-zero entry in each non-zero row must move to the right as we go downward. Third, the entries below each leading entry must be 0. Those leading entries are called pivots. They are the useful landmarks. Unlike most landmarks in notation-heavy math. Now let us reduce A. The first pivot is the one in the top left corner. Use it to clear the entries below it. Replace row 2 by row 2 minus 2 row 1. Also replace row 3 by row 3 minus row 1. Now the first column has zeros below the pivot. Next, move to the second non-zero row. The next pivot is the one in column 3 of row 2. Use it to clear the entry below it. Replace row 3 by row 3 minus row 2. The result is U, a row echelon form of A. The pivots are in columns 1, 3, and 4. Column 2 has no pivot, which will matter soon. It always does. Free things are never actually free. To find nullity, we solve Ux equals 0. The pivot columns are 1, 3, and 4, so x1, x3, and x4 are pivot variables. Column 2 has no pivot, so x2 is free. There is one free variable, so the nullity of U is 1. If you want to see it directly, the equations force x4 equals 0, x3 equals 0, and x1 equals negative 2x2. Now we justify why this tells us the nullity of A, not just the nullity of U. The row reduction from A to U is the same as multiplying A on the left by a product E of elementary matrices. Because every elementary matrix is invertible, their product E is also invertible. Therefore AX equals 0 if and only if EAX equals 0, which is the same as UX equals 0. So A and U have the same null space. Hence the nullity of A is 1. Now rank follows from rank nullity. A has 4 columns, so the domain is 4-dimensional. Rank nullity says rank A plus nullity A equals 4. Since nullity A is 1, rank A is 3. This matches the 3 pivots in the echelon form. The pivots were not just decoration after all. A shocking career upgrade. The example gives the general rule. For an M by N matrix A, reduce A to row echelon form. If the echelon form has R pivots, then rank A equals R. And nullity A equals N minus R, because the non-pivot columns give free variables. One warning. Row operations preserve rank and nullity. But they do not preserve the actual column space. Details matter. Because mathematics enjoys traps with clean handwriting. Let us summarize before row echelon form starts acting like a personality type. Row echelon form organizes a matrix so pivots move to the right and entries below pivots are 0. For our matrix, the pivot columns are 1, 3, and 4. There is one free variable, so nullity A equals 1. By rank nullity, rank A equals 3. Next time, we can use the same row reduction machinery for solving AX equals 0, AX equals B, and finding inverses. The machine has more attachments. Naturally.